Chờ một chút nha mọi người nhé. Đợi các bạn vào. Bây giờ có 25 bạn. Lớp có 40 bạn cơ mà. Bây giờ có 25 bạn. Chờ thầy chú nha. Sao không share được cái màn hình kia? Okay. So, let's start. Let me introduce myself. So should we speak English, right? Here we have all Vietnamese people, so I think we can we can switch between English and Vietnamese. So if you have any questions that you don't understand in English, please ask me and Jen. I try to explain in Vietnamese if you need. So okay, we have a foreign student here. So anyway, we should use English most of the time. Okay, so let me introduce myself. My name is Minh, Nguyễn Đức Minh. I study a master degree and a PhD degree in Germany in the field of digital design. So I think this semester I will teach you about digital design and digital system design. Also, we talk a little bit about IC, digital IC design. Okay. Can you hear me clearly? Is this okay?
Yes.
Okay. So, you can contact me via my, let me note it down in the meeting note. In between, so just wait a moment. So so my name is Nguyễn Đức Minh. Some of you might know me already. Some don't. Doesn't matter. So you can contact me via email. Or drop me a phone call. If you have any question regarding to the class, please let me know. And this course will be digital system design. And this year I will going to teach you about Verilog. So the language that we use is Verilog, hardware description language. Okay. So we should talk a little bit about the role in the class. So we have two sessions per week. One is from, so the first session we will talk about theory, will be in Monday, and from 12:30 until 15. So, and then we have a section, we name it practice. It is in Friday. Is it correct? Let me check. And in the practice section, you will no, it's not a practice. It's not on Friday, but on Thursday. From it's the last two. One, so it will be from teams up to, okay. So So in the theory section, I will tell you about the methodology to design a system, a digital system. And on Thursday, in practice section, my teaching assistant will guide you through several different practical projects, so you understand the theoretical theory more. Okay, so for the mark and assessment, so it's called assessment. What we will have, firstly, you will have I will assess the way you involve in the class. So that means I will ask a question, you can answer the question. I can give you several different tasks during the theory, and then you need to answer this. So this class involved. And this will take you around 10% of the class point. And then you have here and then you have practical, where you will be given a small project that you need to do during the practice section, and it will take you 30%. And then finally you have a project, a final project, where it will be 60%. So in this class, you will you don't need to do examination, writing examination, and in the project, you will do it in a group of 3 students. In the practical exercise, you will do it yourself, individual. Where you need to submit the assignment during the you will do it individually. So it is the way, and also in the class involvement, I also do the how to say điểm danh. I don't know. Where you need to appear in the class. So attendance, class involvement and attendance. Okay. Any question?
Teacher, that means we had no exam, right?
No, we don't have examination. We all because this one is around designing, so we need to do the project. Okay. So you understand, and in the project, when you present your project, I will ask question. It can be practical question, or theoretical question. So it's not only project, but also you can consider it an oral examination also. Okay, got it? So that means in the group, if only one member of the group doing the project, then the whole tree will be failed. Okay, so you need to split the task among your group member. Okay, any other question? So at first, please join the group. Here you see a channel named your class code. Here, please join this one, and then I will upload your list, your name list here, and then you can select you can register for your group member. Is this okay? So let me do it right now. So let me upload here the class member name, and then you will need to do okay. So let me hide. So here, let's register for the group. So you can select, for example, if the first three is in group 1, and then you can choose this one is group 2 and this one is group 2, and please fill in your group number, and note that only 3 students are in one group, so don't choose and select a group of 4. Okay, so we have totally 43, so that means we have 7 groups, and only one group have 4 people. Okay, understand? So let me put this one into the file in the team. Oops, sorry, it's my fault. Let me do it again. Okay. So this group 1. So let me upload it here. Note that it's different from your channel. So the general channel is only contain the course material, but everything regarding to your class will be in the channel number 128329. Okay, so please fill in this one. So it is the first task that you need to do. So let me.
Excuse me, sir. I don't see this channel.
You couldn't see that channel?
Yes.
Let me config it again. Let me configure manage channel. Can you see your channel? No?
No, I still cannot see the channel.
Okay, let me open it and try to setting so you can see the channel. Oh, how can I show the channel to how to set up this? Manage channel. So get link to this channel. So I put it here. I put the link here. So you can click to this and please require to join the channel to see whether you can join the channel. Can somebody try to join the channel? Okay, can you join the channel? Any question regarding to this?
We still cannot see the channel yet.
Oh, can you click on the link?
Yeah.
And when you click on this, what happened?
Yes. Some members send picture in the chat. You can see.
Okay, let me check. YouTube connectivity. What's wrong? What's wrong with it? Do it again. Why do they need to accept? Edit channel. Add member. Channel. Setting. Member permission. Let me try to add you. I will add you later, but let's try to see whether I can add one person. And then after the class, I will ask the other, add the other. Let's see whether I can add. No. Add member. Why couldn't I? Why couldn't I add? It's strange. Something wrong. This is answer. Okay. Hồ Diệp Anh, are you here?
Yes, I'm here.
Yeah. So can you check whether you can join the channel, the class?
Yes, I'm in the class.
Okay. So let me make you an owner. So please help me to add the other. Is it okay?
Yes.
Okay, thank you very much. Okay. So I think it's okay now. So Diệp can you please add the other, and then after that you will see the file here where I upload the name list here, and then you can fill in the group number that you belong to. Okay, so let's do it this week. So next week, okay, so let's do it until Tuesday. So let me do it, doing a nice assignment. Every assignment that turn in on time will be count on your class involvement. Okay, so final. Okay, so team member. The file. Okay, so it will due on Thursday, on Wednesday. Okay. Okay, so it's first thing you need to do during class. Okay, so let's move back to the main content of this today. So let's talk about it about this course. The course is design and synthesis of digital ICs and systems. And let me ask, how many, which one in this class want to follow the direction of IC design? Please raise your hand so I can see how many will join the. So Trung, Huy Hoàng. I couldn't do the. So only two will join the IC design direction. Tú. And how about the other? How about the other? Quân, Đỗ Minh Quân, can you share your future direction? Which direction you want to go into? IC design, embedded system.
I'm still choosing.
Okay, so you haven't decided yet, right?
Yes.
Okay, so let me ask the other one. Lê Bảo Ngọc, which direction you want to follow after the third year, in the fourth year?
Embedded system.
Okay, you will select embedded system. Okay, let's ask one more person. Bảo Long, Ngô Khắc Bảo Long. Which direction? Yeah.
I want to work with cloud.
Okay, cloud computing, cloud technology. Okay, great. So only few, okay, four. So I see 4 people want to join the IC design direction. Okay. So anyway, even though that you don't select IC design direction, I think this course is still very useful for you to understand the computer architecture, know the way a computer are designed. So if you select the direction of electronic and computer engineering. This course is very important and will give you knowledge about the underlying digital system of the computer and the embedded computer. So, what the course will do after doing this course, you will understand how to understand and have knowledge Nhật. You at first so the first purpose is you can you understand and can use design methodology for IC digital IC and system. The second purpose is you know how to use a Verilog hardware description language to model, to design, describe, and simulate a digital system, especially a digital circuit or digital IC. After this course, you will be able to analyze the system requirement, construct the specification of the system, describe the behavior of digital logic combinationally or sequentially using different model, structural, behavior, or the data flow models, and using the hardware description language, you know how to translate or convert an algorithm into a digital system using finite state machine data path methodology or algorithmic state machine data path methodology. Also, after designing or describing the digital systems, you know how to construct a test bench or test environment and perform a simulation to verify that the system works correctly, the functionality of the system is correct. And then if we have in our time, we will mention or we refer to how to synthesize the digital IC into gate level models. But this one is not the main purpose of this course because we don't have enough time. I don't think that we have enough time. So the one that who want to follow the direction of IC design, you will learn this on another course in the 5th year. The course named VLSI design. So we will go more detail onto synthesizing, but this one we don't have enough time to do that. Okay. Of course, you need to work on a team, and you need to present the design plan, the verification plan. Okay. So the content of the course will be 5 things, and we focus on the first 4 chapters. We can divide it into chapters, 4 chapters. So firstly, we in general introduce the digital system and IC design using a hardware description language, a Verilog hardware description language, HDL. And then we learn how to verify the system using simulation method. We learn how to describe the combinational and sequential circuit using Verilog and HDL. And finally, we learn how to translate or convert an algorithm into digital circuit using the finite state machine data path or algorithmic state machine data path methodology. So it's ASMD and FSMD respectively. Okay, so the textbook will be the first one, this one. So you have the book of Michal Siletti and the book name Advanced Digital Design Using Verilog. It's very thick book. It's 1,000 pages. But most of the first part is about logic design or digital logic design that you learn in the digital logic. Did you study digital logic course?
Yes.
Okay. So the first part of the book will be about that. So you need to read the second part about the design methodology, and then you can refer to these two books, another two books, Top-Down Digital Design Flow and Advanced ASIC Chip Synthesis. But this one is for only you can use it for the 5th section of the course, but I don't think we have enough time. So here you need to do you need to attend the class and do homework and also do the final project of the homework. So I have talked about the grades already. So we modify this one. So you have it already in the meeting note. So here's the course content. I will not go too much into detail about that. We will go through it later. Every week we have the content is a lot actually, to be honestly. So you need to self-study quite a lot in order to do the last final project. I don't have enough time to mention all about that. So we don't have enough time. So you need to read the reference book, the textbook, and do the exercise. Okay. So here's course content. So this one is already copied into our team, so you can download it and refer to it. Let me show it to you. So here, is this one in the file. I have here put here the references. Let's see where I can rename it. So the references. So here you have our textbook, the Advanced Digital Design Using Verilog. Also, I put it here the slide, which you can refer to it, because in this course I will not give you the slides. We don't have slide for this course, so you can refer to the Eric Kaufman slides. Here I put the material for digital compiler of synopsis, where you can use it to do the practice, or you will use another one. Here's a textbook, and also here I put a mind map, in which I summarize all knowledge that are taught in this course. So let's click on it. Now, let me open it. and then show to you so you know where to find out the summarize of the course. One moment. One moment. One moment, please. I think you can open it normally. Normally I can open it. One moment. One moment, please. Okay, it's not supported anymore. Oh, sure. One moment, please. Doesn't support it anymore. Okay, let me find out the way to export it into another format. Okay, this one is very important. See how can you open this and view it. Anyway, okay, let's move on. So it is about the references, and in the this one, the lecture note, let me rename it so foreign student can. So in lecture note, you have our note that I have already done before, so you can refer to it. If you don't understand, for example, in this one, you have methodology flow, you have introduction of Verilog, and so on and so forth. Try to, okay, let me see whether I have renamed it already, and so I upload for you another one that is better to refer. One moment. Okay, so it's better here. So it's better to use this one. So I have it here, everything. Refer to it, so it will be better. Okay, so then here you will have our notes that you can refer to it. Okay, so any question regarding to the course purpose and content? Any question? Hello? Hello? Hello?
Yes, sir.
Yeah, it's okay, right?
Yeah, so all the note in this lecture note, right?
Yes, yes.
Yes, thank you.
Okay, so you can refer to it, print it, and refer to it before the class. So everything is there. So you don't need to get it somewhere else. So let's start with the first chapter. Okay, so we need to mention about the tool. So we need the tool to do this. So let's open again the meeting notes. Okay, so the course purpose is already here. Let me copy it to this one. So you purpose and expect outcome. Okay, and then how about the tool? Which tool you need to use and you need to install in order to do the course. So the tool. Most of the time we will do the course. We need to simulate. Software tool. And if we have enough time and you can come back to the school, the university, then we can do some physical synthesis and load it into FPGA board. But most of the time we need to do simulation. So what we have is the simulation tool, software. We will use the model sim. Sometimes you call it a Questa sim. So try to search it and download correct. Okay, and then for synthesis, we do the synthesization in FPGA and load into FPGA. So you can use HUST. You have a student editor. You can download it from intel.com. And then we use HUST. And in the lab, we will have the Antera, or now it's Intel FPGA board, FPGA synthesis. So it's a tool. Any question regarding to the tool?
No.
Okay. Good. So now let's start with some quiz. Let me ask a question about. So now we need to how to say remind you about the digital logic knowledge. So let's start with digital logic fundamental. Okay, so let's discuss a little bit about digital logic. So you have learned about digital logic. So let me ask you several questions regarding to digital logic. Open it again. Fundamental of digital logic. So firstly, anybody can tell me about okay, that let me do the involvement check. Okay. Okay, so this one is the 1st September. Let's do it. So can anybody define for me the electronic circuits? Which is electronic circuit? If nobody want to volunteer, then I will ask you randomly answer question. Let me choose randomly. Nobody volunteer? So number 15. Lê Nguyên Dũng. Lê Nguyễn Dũng. What is the electronic circuit? Dũng có đây không ạ?
Teacher,
Yes.
you mean Lê Hải Dũng?
No, I mean Lê Nguyễn Dũng.
I'm Lê Hải.
I am Lê Hải Dũng ạ.
Okay, so it's not your. So Lê Nguyễn Dũng is not here. So let me give him 0. So I have 20. So Giang Vũ Tuấn Hải. Is Hải here? Is Hải here? Okay, so what is the electronic circuit or electronic equipment? Hi, can you answer the question? Okay, anyway, so so easier question. So okay, so you do Google search, right? But I want you to answer based on your understanding. I don't need a copy and paste. Okay, so it's too long. Just answer very shortly. Electronic is the circuit that remote. What do you mean remote? Đạo.
Em nghĩ là nó có thể điều chỉnh được dòng điện chạy qua.
Okay, so you mean control, right?
Control the current. Yeah.
Okay, you can control the current. It's somehow correct. So let me ask another. So I will give Đạo 1 point. Let's say one tick. Okay. And also even though Tuấn Hải you copy, but I don't think it's correct. So let me ask another easier question. What is different between a lamp and a radio?
Can I answer the question?
Yes, sure. What was your name?
My name is Anh Tú.
Okay, so what's different?
So I think they are both electric circuit, but with the lamp we call it electric circuit, but the radio we call it electronic circuit. But I think in the radio we have active component like transistor, where in the lamp we only have passive component like resistor or some kind light filament or something like that. So that's why the radio called electronic circuit and the lamp called the electric circuit.
Okay, thank you very much. Yeah, it's correct. It's somewhat correct. Yeah. So you what's your name, please?
My name is Tu.
Tu. Yeah, sorry. So it's correct. So I give you 1 tick for this answer. So you see that it's electronic circuit. You have active component, you have transistor, you have gate, logic gate, so on and so forth. And you can, as Đạo wrote down in electronic circuit, you can control the current, you can change the current, you can amplify it, you can change the shape of the current, you can change the timing of the current and the signal in general. So you have electronic. So electronic means that you use active and passive electric component to modify, to amplify to process the signal. And one more thing that I want to emphasize is that in electronic circuits, you normally assign or interpret signals with meaning. So that means you give a signal some meaning. You interpret it. You how to say? You explain the meaning of the signal. So, for example, in radio, you know that you receive the magnetic electromagnetic wave and consider it as a signal that carry your voice, your audio, somewhat like that. Is this okay? So that means the signal you receive, you process, have some meaning, have some interpretation. Understand? Okay. Yes. Active, passive, electronic component. You still see my my display component. To process, modify, even analyze electrical signal. When you say electrical signal, you mean represent it using voltage and current, right? Answer. Okay. And also signal are interpreted or you can say that signal carry, have meaning or informational meaning. Okay, so it's differentiate the electronic circuit from electrical equipment. Okay, in electrical equipment, you only transfer the power of electricity, but here you need to modify, you need to convert everything. Okay, so let's discuss a little bit about classification or types of electronic circuit. So which kind of electronics do we have?
I think that we have analog and digital circuit.
Analog and digital circuit. So, what are differences? Who answers the question?
It's me. I think that the analog circuit combine the like resistor or the capacitor and the current and the voltage may vary continuously.
That's what I want to hear. So in analog circuits, you have current and voltage continuous signal. Continuous here means continuous in value as well as continuous in time. Okay, so process continuous. Continuous signal in value and in time. Okay. So who answers that question?
Me, Phạm Huy Hoàng.
Okay, Phạm Huy Hoàng. You please mention your name because sometimes I couldn't look at the meeting class.
Yes.
The team. So Hoàng, I give you one tick. 1 minute. Why didn't I find you? Have you registered for the class, Hoàng?
I'm sorry.
Have you registered for the class? I couldn't see your name in the class.
I saw my name in the Excel file.
Oh, really? Let me search again. Here. Sorry. I found it. Okay. So I give you one tick. So how about the digital circuit?
I think that the electric signals take on discrete values,
Mm-hmm.
and it represents logical values.
Mm-hmm. Mm-hmm. Discrete. Discrete. In value and in time. Okay, so in digital circuit, we can divide it into two types of circuit. It's combinational and sequential, right? Okay. So, okay. Anyway, let me stop a little bit and introduce my teaching assistant, anh Triển. Can you open your camera and introduce a little bit about yourself, so and your young brother can see your face. Triển, are you still here? I saw Triển, but I don't know whether he left. Triển, can you hear me? Hello, Triển. Okay, anyway, let him do it later. Let me mention him here. Okay, so let's continue. So we have combinational and sequential circuit. Can anybody can explain a little bit about combinational and sequential circuit? Hello. Hello. So
Can I answer the question?
yeah, sure, please.
I think sequential circuit is a type circuit that the output also depend on the previous input and the current input, whereas the combinational circuit is just only depend on the current input.
Thank you. It's correctly. It's very correct. Past and present input and combinational one. Yeah. Right. Okay. So it's about circuits. Let's talk a little bit about mathematical point of view. From mathematical point of view, so who answers question?
My name is Tu. Okay.
Tú. Đặng Anh Tú, right? So you have another tick. So you have Tú. So the tick will be sum up at the end of the semester and give you attendance grade. Okay, let's talk about mathematical fundamental of the circuit. So let's consider the combinational circuit. So from which mathematical we construct the combinational circuit. Understand my question? So let me ask again. So what is the mathematical fundamentals of combinational circuit? Oh, what is a mathematical representation of combinational? Yes, one is correct. So can you further elaborate your answer? So you say that combinational circuit is represented by Boole algebra. So can you link between the circuit component with the Boole algebra elements?
Yes, I think we can use the OR and AND logic circuit to link the component. Maybe we can use the SAW one and NOR one.
So let me let me ask more detailed question. So in circuit, you have input and output, right? So the input and output of the combinational circuit are related to which element in the Boole algebra? The input, the output, and the signal in general. What's the relationship? You understand my question?
Can you repeat it again?
Yeah. So in the circuit, you have inputs and outputs. So inputs and the outputs of the circuit are related to Boole algebra elements. So which are the elements of the Boole algebra that related to input?
I think it's the binary variables of the Boolean algebra.
Yes, exactly. You are correct. So signals in circuit are related or are represented by variables, or you can say Boole variables or binary variables in the Boole algebra. So it's the first thing. We have signal are represented by Boole. Okay, and now how about the gate? The gate in the circuit, in the combinational circuit, are what in Boole algebra?
The logic operation.
Yes, exactly. Thank you. It's very correct. The logic Okay. So that means when you have a Boole function or Boole equation, you can implement that Boole equation, Boole function by a combinational circuit. So I mean here that Boole function are implemented by a combinational circuit. Or you can say that combinational circuits are modeled or are presented by Boole functions. Okay. From that, you have the way to represent the Boole function using through a truth table. You have a cardinal diagram, okay, and you have the way to optimize the Boole function using cardinal method, or you have Quinn McCloskey method. So you have represent Boole function by truth table. Okay, using incomplete truth table. Using cardinal diagram. And then you have optimize Boole function by cardinal method or Quinn McCloskey. Method. Okay, but in this course, we don't need to do it manually. Everything will be done using our synthesize tools. You don't need to do it, but you still need to have basic knowledge so you can understand how the synthesizer tool do it automatically or semi-automatically. So, okay, let's move on to finite state machine and sequential circuit. So it is the same as in combinational circuit. You have the sequential circuits are modeled or are presented by finite state machine, and you can say in a different way the sequential the finite state machine is implemented by sequential circuit. So let me write down. So sequential circuit are represented or modeled by FSM, or in another way around, FSM are implemented in sequential circuit by sequential circuit. Okay, now let's map between the sequential circuit components and the finite state machine. So you all know that the finite state machine consists of input symbol, output symbol, and states. And finally, we have the transition between states. So can somebody tell me about the mapping between finite state machine and FSM. Okay, let me write down FSM. FSM have several elements. We have state S, or set of state S. We have input symbol I, output symbol O, and transition state between two states. Because it's transition between two states, I normally can name it S1 to S2, represent it like it. And sequential circuit. You have input signal, output signal. Very note here that I use the name input symbols and output symbol. And in sequential circuit, I use the name signals. And input signal, output signal, register, or flip-flop. Let's say flip-flop. And combinational circuit. So, what is the relationship between the element of finite state machine, FSM, and sequential circuit? Can anybody tell me about it? Lúc nãy Quân thầy chưa cho điểm đúng không? I give Quân. Excuse me. Who is answer? Lê Minh Quân or Đỗ Minh Quân?
I'm Lê Minh Quân.
Okay, I give you one tick.
Thank you.
So, can anybody answer or give me the relationship between the finite state machine element and sequential circuit elements or concept, whatever? Okay. So, flip-flop, yes, flip-flop. You know about the concept of flip-flops? Nguyễn Lê Trung.
Yeah, I'm here.
Yeah.
I think we use flip flop to transform from FSM to sequential circuit. Yeah, it will save the state and yeah, and it provide different output for each state.
Okay. Yeah. Somewhat precise, not yet clear enough, but it's okay. I think I can give you one tick for your answer, Chung. Any other answer? Okay, so you have finite state machine. Let me draw something. Whether I can draw it here? No. No. No, it's the highlight. No. Yeah, I cannot draw thing. Okay, so let me draw it. How can I draw it? Let me use OneNote. Okay, anyway, let's take a short break. We will come back at 2:15. Okay? So let's stand up, do some physical exercise. Come back. Okay. Let's continue. So, let me draw. Okay. Okay. So in finite state machine, we have state, let's say S0, and then we have under some input I1, we move to S1, and then here under the input I2, we stay in S2. Okay, so maybe we go to S2. Under the input I3, and here we stay here in I4. Sum up like this. Then we go here. Under the same input I1. And here, let's say here is okay. So here we have O1, and here we have O1, and here we have the output O2. Okay, so let's ask the very easy question. Which kind of finite state machine is it? More or melee? Hello. So Vanessa, I see Wanasekara. He answers Wanasekara. Okay, so here we have Le Chung is more. More is not 2 O. It's only 1 O. Okay, mom. So I give each of them 1 stick. Let's say 1 star. Chung. Le Chung. 1 moment. 2. Wanasekara. 1 star. Lê Hoàng Thái. 1 star. Yes, it's more. Nguyễn Võ Ngọc Minh. Okay. Okay. So here we have it. And here we have the sequential circuit. The sequential circuit contains a combinational circuit which connect the input. Which one is this? How call it? Input signal, we haven't give it name, but here we give it the name X. And the output signal is named Y. And the flip-flop name V. The combinational circuit is C. Okay. So here we have combinational circuit C with which have input is X and output is Y. It may contain several signals. And then we have the flip-flop V, the flip-flop which controlled by clock. And we call it V. and then. So, what is the mapping between this one and this one? Anybody can answer the question? So, what is the relationship between V and S, X and I, and Y and O? What is the relationship? It's very important. If you understand this one, then you can easily write Verilog code. Otherwise, you cannot. What is the relationship? So what is a relationship? Here, when I mention the relationship, I mean the mathematical relationship between X and S. Let me ask a more detailed question, concrete question. For example, here I have 3 states. How many signals are there in the X?
Four.
How many?
4.
4. Why is 4?
I1, I2, I3, and I4.
I have only 3 S. 3 steps, S0, S1, S2.
But we have 4 input.
We have, yeah, sorry, yes, we have 4 input, but we don't need up to 4 signals. So here, how much?
We need 2 signals.
Yes.
One
Japan, why 2 signal?
You need 2 signals because then you will have 0, 0, 0, 1, 1, 0, and 1, 1.
Exactly. We encode 4 input symbols by 2 signals. Yes, exactly. So the answer here is, so we say that the relationship, the first letter is input symbol are encoded by input signal. Okay. So similarly, we have output symbol are by output signal. Okay, so that means we have 4 input symbols. We need 2 input signals. Symbol is different from signal. Okay, so I give Diệp Anh 1 star, and also Vũ Hoàng Long. Vũ Hoàng Long, I give you 1 more, even though you still need somewhat more correct answer. Okay, but to encourage, yes, you can give it. Thank you. 1. Okay, so we have output signals. So here we have 2 output, O1 and O2. So that means you need only 1 signal to represent 2 input, 0 and 1. Okay, similarly, we have 3 states. How many flip-flop do we need? Yes, 2 is correctly. And Vanasekara is 2. I gave you both 2 star. Put it here. Let's have one more star. So, okay. So that means we have here 2 input signal, 1 output signal, and 2 flip-flop. So we also denote the input of the flip-flop as V strict. V prime means that it is the next state variable. And here we name it V as a current state variable. So here we have V, and here we have V prime. Okay. So that means the V prime represent or encode the next state, and V encode the current state. So let me note it down here. So next state encoded by next state variable. So the input signal X, Y, and here's S, as here's V prime. Here's our input symbol is I, output symbol is O, and next state are encoded by S prime, and current state is very important in the next few lecture, as are encoded by state variable V. Okay, so it's the element component, and let's talk about the final combinational circuit. Combinational circuit C is actually contain 2 parts. So you can say so. The first part is this one, this part. We call it the lambda part, and this one is the delta part. So the lambda part is actually represent the output signal that calculate Y from X and V, and the delta part represent the next state function that calculate V prime from X and V. Okay. Understand? Any question? I have here delta function calculate the V prime equal to delta. Let me see whether I can insert delta here. No, it's not possible. V and output, this is size. That's that function. Right? V Y equal to lambda this and V. Okay, any question? Any question? Understand?
Yes.
Okay. It's very important because we base on this and then we try to, if you understand this fundamental, it will be very easy to model everything using Verilog, using hardware description language. Because remember that hardware description, I will tell you a little bit about that. Hardware description language is actually just only to describe the circuit, hardware circuit. So, okay, so before going further, let's talk about another things. Let me bold this one, import it. So now it's become complex. So let's talk about basic building block for logic design. So what is a basic block for combinational circuit? What are learned in the digital logic class? Name several for me.
I think it's like decoder, encoder, and a selector.
So link, you mean what? Encoder? What else? Decoder?
Encoder.
Yes, and what else?
Selector.
What? What is it?
Selector.
Okay, selector. What else?
Half adder.
What?
Half adder.
Half adder.
And a full adder.
Half. How I can pronounce it? Half adder. Half adder. Is correct? No. And full adder. What else? Okay, link. I give you one. Tick. Thank you. It's correct. But I want more. Anybody can give me more? So CLA, what is CLA, Hoàng? Hoàng, can you give me? Yes. Can you give me the full name of CLA?
This is a carry look ahead.
Yeah, carry look ahead. It's actually it's not a basic building block. Okay. Yes, exactly, Bình. You are correct. I expect that you have and or not, sure, no, and. Okay, so actually you use the logic gate. One moment, please. I have an answer. I have a phone call. Sorry. Okay. Let's continue. Okay. So we use the basic block to construct our combinational circuit. Yes, of course, we need register or flip-flop, of course. And how many types of flip-flop do we have?
4 types.
What?
There are 4 types.
Yes. What is this?
JK, SR,
yes.
T
SR,
and D.
T and D, JK, SRS. I like to call it RS. I don't know why, but you can call it SR. Yeah. S and Z, T and D. Okay. Who is this? Ngọc, right?
I'm Hoàng.
Hoàng. Okay. I give you one. Yeah. One moment. I give you one. Tick. So yes, exactly. So we have this one and we use this. Phương Linh, when you mean the selector, do you mean multiplexer? Is it correct? You select one of the input S0 or S1 depend on a controller or depend on selector. Is it correct, Linh? Is this one? This one? When you mention selector, is this one?
S to control.
Yes, you have S to control. Yes. Okay. Thank you. It's correct. Let me delete it. Okay. Oops. Thank you, Linh. Okay. So we have this one. You can call it selector, or actually it's called multiplexer. So I prefer multiplexer. So it's standardized. And you have, of course, demultiplexer. So the demultiplexer is the one like this. So you give one here, and upon an S, this one will go this way or this way. The same one. Okay, and then based on this, you can build up a more complex combinational circuit. And using both the combinational elements as well as flip-flops, you can construct the sequential circuit. Okay, so of course, in the digital logic class, you have learned how to connect the symbol or the basic blocks into a circuit, and we name it a discrete circuit. Discrete here doesn't mean the discrete signal, but the circuits that contain a lot of discrete elements. Okay, you got it? Any question? So that means here you have discrete circuit. Here's a discrete circuit. That means you connect the AND gate with an OR gate, and maybe you connect it through a multiplexer like this, and connect it with one here, and here you have a select, and so on. And maybe this one will go to a flip-flop. Here, when you say this one, you have a discrete because it contains a discrete elements. Okay, but now in this one, we will consider the two methods to implement the combinational circuit and the combinational circuit as well as the sequential circuit. We say that is implementation technology. So let's talk about implementation technology. So let me copy it. So we have implementation. Have you heard about FPGA and ASIC? Anybody heard about FPGA and ASIC? So we have here the FPGA. And let's first talk about ASIC. What is ASIC? What is it? Anybody can give me some hints about that?
ASIC is designed for only one suppose. They run the function for its whole life.
Yeah, somewhat. But a general purpose processor is also named ASIC. Application specific integrated circuit. Let's talk about the technology, the underlying technology, but not talk about the purpose when we're talking about underlying technology. Let's talk about that. So how can we implement a NOT gate using transistor? Have you heard about it or learned about that before? Oh, sorry, I have another phone call. Terrible, sorry. Okay, so implementation of digital circuit. Let's talk about technology. So it's technologically implementation. Technological. Okay, how can we implement a NOT using transistor?
I think that 2 PMOS are used to make inverter.
Okay, 2 PMOS or 1 PMOS and 1 NMOS?
I think that 1 PMOS and 1 NMOS.
Yes, exactly. Exactly. Thank you. Who is this? Can you introduce?
I'm Phạm Huy Hoàng.
Phạm Huy Hoàng. Okay, I give you one more star. So a lot of stars is given. So we have here a NOT gate. Okay, so here's the transistor level of the NOT gate. Okay, so you have NOT gate, it is a component in gate level. Here you have a transistor level of a NOT gate, and at layout gate you have this. Here you have, from the top view, you have the connection between two transistors. Here you have one AND gate, NMOS transistor. Here you have PMOS transistor. And in 3D view, you have here, you dig down into the silicon surface, and then you you need to dig down, and you need to implant. You need to implant different material into the silicon to make the NOT gate. So, and here's side view. Can you see it clearly? So here you have N well, and then you have NLP, and then you connect them together, and here you have. Okay, got it. So here's the way you actually construct a NOT gate in the real in the physical world, in the reality. So you need to construct it like this. Okay. So now the ASIC means that you construct a lot, you connect a lot of gates, the NOT gate, the NAND gate, the OR gate, and so on and so forth. You put them into a very dense area, and then you manufacture it, or you fabricate it in a silicon surface, or you call it wafer. Okay, so when you put all transistor of the logic gates, the flip-flop, into a very dense area on the wafer, you have the ASIC implementation of the circuit. You got it? You understand? Anything not clear? For example, here you have a SOR gate. It looks like this. Here's you call it the layout, and using the layout you can fabricate. Here's the layout of a SOR gate. Using this layout you can fabricate, or you say that you create a SOR gate on the wafer and connect them all together. You have an integrated circuit. Okay, any question? Hello? Tired?
No question.
It's ASIC. So that means in order to make this or to design an ASIC, you need to at first create the gate level. The gate level, that means connecting many simple logic blocks together to create a gate level. And from the gate level, you create the transistor level. And finally, you create the layout. And from the layout, you can fabricate the circuit. Okay. and depend on the way you create the gate level, the transistor level, and the layout level, you have different way to design your ASIC. Got it? Okay, so let me summarize it a little bit. This is logic or basic digital logic block, digital basic logic, digital basic block connected and to create a circuit, digital circuit. Gate level and then converted into transistor level and then layout or physical layer, and finally fabricate in on the wafer, silicon wafer. Okay. Then you have the ASIC implementation of the circuit. Okay, and if you have a fully customized circuit, you need to design from the logic level to gate level to the transistor level and finally physical layer or level, physical layer level. If you design yourself all level, then you have a fully designed or fully customized ASIC. So fully customized ASIC is all level manual design somewhat, but normally there's only few companies do it now, fully customized ASIC. For example, Intel, they do it fully. For example, if you have an iCore 7, then most of the parts are manually optimized, designed manually. But most of other companies, they only do several level themselves, and then otherwise they use the design provided by the other company. For example, sometimes people only do gate level design, and then for the transistor level design and layout physical level, they use the library provided by the other companies. It's similar as when you develop a software. Maybe you use the library provided by Microsoft, provided by Google, provided by ST Micro Electronics. Some other company provided you the libraries, and you just call the function inside the library. You don't need to build the library yourself. So you have semi customized ASIC. So transistor level or and or layer, physical layer level are provided by other party. Okay. Understand? Any question regarding to this? Okay. So if you don't have any question, let's do further. So let's talk about FPGA. Do you have enough time when the class finish? 3, right? Hello.
Yes.
Okay. So we continue next week. So today I give out 11. 17. We give a 17 star. So I do hope that next time I get more. I will give more. So let's do an assignment. Another assignment. Okay. Implement 7 segment decoder using mục. So you know the 7 segment decoder. So the input is the BCD, output is the 7 signal on 7 segment. Okay. Now you need to implement this using books. And so if you implement this, then next time or the next week we can describe it using Verilog easily. Okay, so let's do it until next week. On Friday, we can correct it on Friday. Everybody need to turn in this. It will be considered as one of assessment. Okay, so let's do it. Any other question regarding to the class?
Sorry, teacher, can you talk about 7 segments?
Oh, you don't know about 11 segments?
Didn't have learned about it.
So this one is 11 segment. Let me copy it into the notebook. So 11 segment flat and decoder. So here's, oops, sorry, copy image. So here's the 11 segment. You know about it? So it can display the number, the digit number. So you control it using A, B, C, D, E, F, G signal, and maybe DP, but you don't need DP. So if the A is 0, then the let A light, bright, okay? And similarly to the other signal. And so that means if the input is 0, then the LED will be A, B, C, D, E, F, G will be equal to, you need to line up A except G. So that means you will line it up. Line up means this. Okay. Understand? And then if the input is equal to 1, then you need to line up B and C, right? B and C. B and C means that A, B, C, D, E, F, G will equal to B and C. So 1, 0, 0, and then 1, 1, 1, 1. Okay. Got it?
Yes.
Okay. So let's do it. You can do it using normal symbol get, or you need, actually I want you to do it using MUX multiplexer. Okay.
Yes, sir.
So, and remember that the input is BCD. You know BCD?
Yes, it's a binary coded decimal.
Yeah. Yes, exactly. Okay, so let's do it, and then we can correct it next on Friday. Okay. Please turn in before that. We will have a lot of assignments. Sorry. Let's do it. Okay, bye bye. See you on Friday.
Yes. Goodbye.
Bye bye.
Goodbye, teacher.